So the questions in this tutorial deals with solving quadratic equations by using k-substitution. In question 1 here, it says showing all necessary working, solve each equation. And we have the first equation here. Now, what's important to note is that the first y has a power of 4, which is twice the power of the second y. 4 is twice 2. So this is what we call a hidden trinomial. So a hidden trinomial. And when we have a hidden trinomial, we can use k-substitution. We look at the middle term, which is negative 5y squared. So we make the variable in the middle term here equal to k. So we're going to let k equal y squared. Now we substitute it into the equation. Now if k is equal to y squared, then y to the power 4 will equal k squared. Because y to the power 4 is y squared all squared. And we know that y squared is equal to k. So y to the 4 will give us k squared. We can plug the k's into our equation here. So y to the 4 will be k squared. Then negative 5y squared will become negative 5k minus 4 equals 0. And we end up with a quadratic. We can use either substitution, or rather we can use either factorization, or we can use the quadratic formula. However, if you try factorization, you'll see that it won't work here. So we're going to use the quadratic formula. So k is equal to negative b plus or minus the square root of b squared minus 4 times a times c. This is all over 2a. So 2 times 1. We can simplify this. A minus times a minus is a plus. And we can work out what's under the square root here, and it comes to 41. Of course, you can use your calculator. So then k is equal to 5 plus the square root of 41 all over 2, or k is equal to 5 minus the square root of 41 all over 2. But now remember that we let k equal y squared. So we can bring back the y's. So y squared will equal 5 plus the square root of 41 over 2, or y squared equals 5 minus the square root of 41 all over 2. Now, this answer here will be invalid because we're going to get a negative out of here. And no number squared can give us a negative answer. So this answer will be invalid. And that means that y squared is only equal to 5 plus the square root of 41 all over 2. Now, we can solve for y in this equation by taking the square root on the right-hand side. So y will equal plus or minus the square root of the right-hand side and we can do this on a calculator, and we find that y equals plus or minus 2.39. So this is on a calculator. So in B, we have 4x minus 11x to the half plus 6 equals 0. The first x has a power of 1, whereas the second x has a power of a half. So 1 is twice a half. So we know that this is a hidden trinomial. And we can let the middle x be equal to k. So let k equal x to the power of a half. Now, to look at the x here, if k is equal to x to the half, then x we know is x to the half all squared. In other words, x then will be k squared. And we can plug in our k's, so we get 4k squared minus 11k plus 6 equals 0. We can use either factorization or the quadratic formula here. And I'm going to use the quadratic formula. So k is equal to minus b plus or minus the square root of b squared minus 4 times a times c. And this is all over 2a. So a negative times a negative is a positive. We can use a calculator here and work out what's under the square root. And we find that it's equal to 25. We can simplify this. So k is 11 plus 5 all divided by 8, which is 2. Or k is equal to 11 minus 5, which is 6 over 8. And we can simplify this to 3/4. Now we can bring back our x's. Remember, k is equal to x to the power of a half. So then that means that x to the power of a half equals 2 here, or x to the power of a half equals 3/4. We want to solve for x, so we want to get rid of the power here, and we can do so by squaring both sides of this equation. So the 2's will cancel here, and we have x equals 4. We do the same here. We can square both sides. And here we find that x equals 9 over 16. So we have 2 over the square root of x equals the square root of x minus 1. Whenever we want to solve an equation, we always want to get rid of fractions. So we want to get rid of the fraction on the left-hand side. And we can do so by multiplying through by the square root of x. Then on the left-hand side, the square root of x will cancel, and we're left with 2. Then on the right-hand side, we have the square root of x times the square root of x. Now, remember this rule of thirds. The square root of a times the square root of a is equal to a. So then on the right-hand side of this equation, we have square root x times square root x, which is x. And 1 times square root x is square root x. Now, what's important to note is that we can write the square root of x in exponential form as x to the half. We want to bring everything to one side, so I'm going to bring the 2 to the right-hand side here and flip the equation. So x minus x to the half minus 2 will equal 0. Now, what's important to note is that the first x here has a power of 1 that we don't write. And the power of the second x here is half the power of the first x. So this is a hidden trinomial, and we can use k-substitution. We're going to let the second x equal k. So let k equal x to the power of a half. We can substitute in k. So if k is x to the half, then x to the 1 will equal k squared. Because x to the 1, or just x, is x to the half all squared. And we know that x to the half is k. So this is k squared. So we're going to get k squared minus x to the half is k minus 2 equals 0. We can factorize this. This is a quadratic or trinomial. And in solving for x, or rather solving for k, k will equal 2 or k will equal -1. Now we can bring the x's back in. Now remember that x to the half is k. So that means x to the half equals 2 or x to the half equals -1. We want to solve for x here so we can raise both sides to the power of 2. So we're squaring both sides. The 2's will cancel here on the left hand side and we have x equals 2 squared, which is 4. This answer here is invalid. Now, just to explain that, remember that x to the half is the same as the square root of x. So we're saying here the square root of x equals -1. Let me use a different color here. So here we're saying the square root of x equals -1. Now, the square root of a number can never give us a negative answer. And hence, this answer here is invalid. And x equals 4 only. So x equals 4 only. Then in question 2 it says, by using a suitable substitution, solve this equation. Now, the first step will be to get rid of the fraction here. And we can do so by multiplying through by 2x minus 3 all squared. Then on the left hand side here, we'll have 2x minus 3 all squared times 2x minus 3 all squared. In other words, 2x minus 3 to the power of 4. Then in the second term, the 2x minus 3 squared will cancel when we multiply it by this. So we're left only with 4. And then we multiply the 3 also by 2x minus 3. So minus 3 times 2x minus 3 squared, and this equals 0. Now we want to rewrite this equation in descending powers, or with descending powers. So it's 2x minus 3 to the power of 4 minus 3 into 2x minus 3 squared minus 4 equals 0. So now you should note that the power of the first term here is twice the power of the second term. And that means it's a hidden trinomial. So we can use k-substitution. We're going to make 2x minus 3 all squared equal to k. So let k equal 2x minus 3 all squared. So then on the left hand side here, 2x minus 3 to the power 4 will equal k squared. So k squared minus 3, and 2x minus 3 all squared is k. So minus 3k minus 4 equals 0. Now we can factorize. We have a trinomial here. And we see here that k is equal to 4 or k is equal to -1. And that means that 2x minus 3 all squared. So 2x minus 3 all squared must equal 4, or 2x minus 3 all squared must equal -1. This answer, of course, is invalid. So invalid. And the reason is that no number squared can give us a negative answer. So we know that 2x minus 3 all squared can only be equal to 4. So we can solve this equation. We can take the square root on the right hand side. So we get rid of the square here by taking the square root on the right hand side. So plus or minus the square root of 4, which is plus or minus 2. And now we just solve for x. So 2x will equal 3 plus or minus 2. And x is equal to 3 plus or minus 2, all divided by 2. So therefore, x will equal 3 plus 2, which is 5, divided by 2. So 5 over 2, or x equals 3 minus 2, which is 1, divided by 2. Of course, we could write these answers with 3 significant figures. So 5 divided by 2 is 2.50, and a half, of course, is 0.50. Let's look at question 3a. We have to solve this equation. So let's do that. Now, we first want to get rid of the fraction here by multiplying through by the square root of y. So the square root of y times the square root of y is equal to y. So here we're going to get 6y. Then multiplying the second term here by square root y, the square root y will cancel here, and we're left only with 2. Then 7 times square root y is 7 square root y. Now, remember that the square root of y is actually y to the power of a half. We want to write this equation in descending powers of y. So it's going to be 6y minus 7x, or rather 7y, to the power of a half, then plus 2 equals 0. Note that the y in the first term has a power of 1. And the y in the second term here has a power of a half. A half is half of 1. So we know this is a hidden trinomial or a hidden quadratic. And we can use k-substitution. So we let the middle y here, or the middle term's variable, y to the half, equal to k. So let k equal y to the half. Now we can rewrite this equation in terms of k. If y to the half is equal to k, then y to the 1 will be k squared. Because remember, y is the same as y to the half, all squared. And y to the half is equal to k. So y will equal k squared. So rewriting this equation in terms of k, we're going to get 6y, and y is equal to k squared. So 6k squared minus 7y to the half, and y to the half is equal to k. So minus 7k plus 2 equals 0. Now, to solve this equation, we can either factorize or we can use the quadratic equation. I'm going to factorize. So negative 4k minus 3k will give us minus 7k. Negative 2 times negative 1 is positive 2. And 3k times 2k is 6k squared. So when we factorize, we should always check our working. We can solve this equation, and we see that k equals 2/3, or k equals a half. Now, remember that k is y to the half. So that means that y to the power of a half equals 2/3, or y to the power of a half equals a half. We want to solve for y, so we want to get rid of the powers here. And we can do so by squaring both sides. So the 2's will cancel here, and we'll be left with y. On the right hand side, 2 over 3 all squared is 4 over 9. For this equation, we can raise both sides to the power of 2 as well. We can square both sides. The 2's will cancel here, and we're left with y equals 1 over 4. Then in part B of this question, it says hence solve this equation. The word hence tells us that we must use our results from A to solve B with. Now, if we compare these two equations, we see that they are identical, except that where we have a y in the first equation, or when we have a y in the first equation, we have the tan of x in the second equation. And that tells us that the tan of x is equal to y. So let's apply that. In A, we saw that y was 4/9. So that means that the tan of x equals 4/9. Or y equals 1/4. And that means that the tan of x equals 1/4. We need to solve for x. So x will equal the inverse tan of 4/9 here. And here x will equal the inverse of tan, the inverse tan of 1/4. So we can do this on a calculator. And our one answer is 23.96, which is 24.0, correct to 1 decimal place. So that's in degrees. Then we also want the inverse tan of 1/4. And this comes to 14.0 degrees. Now, these are not the only solutions. What's important here is that the tan of x equals positive 4/9 here, and here it's equal to positive 1/4. So now we need to look at the cast diagram. So the cast diagram, C-A-S-T. So everything, all the trig ratios are positive in the first quadrant. Only sine is positive in the second. Only tan is positive in the third. And cos is positive in the fourth quadrant. Now, so tan will be positive in the first quadrant and in the third quadrant. And the third quadrant is 180 degrees plus x. So these answers we got here of 24.0 degrees and 14.0 degrees are the solutions in the first quadrant. We still need to get the solutions in the third quadrant. And we can see the third quadrant says 180 degrees plus x. So we need to add 180 degrees to these answers. So then x, in addition to x being 24.0 and 14.0, x will also be equal to 24.0 plus 180 degrees. And it will also equal 14.0 degrees plus 180 degrees. So we can do this on a calculator. Well, this one is going to be 204.0 degrees. And this one is going to be 194.0 degrees. So then we have four solutions. We said 24.0, 14.0, and also 204.0 and 194.0 degrees.